All right, so we're going to try and solve this problem here. We have two masses. We have one that has 10 kilograms and one that has 300 kilograms, and it's 2 meters apart. All right. The question is how strong is the force of gravity between these two objects? In order for us to do that, we're going to be using Newton's law of gravitation, which is big G m1 m2 over r squared. It helps to kind of show the forces between these two objects. So, like, what direction is this mass pulling on this guy? And we can say that this is being pulled in this direction. And third law, right? When you pull on something, it pulls back. So you will also see something like this, equal and opposite. So they're both pulling on each other. Now you call one mass 1 and you call one mass 2, and then you move forward, right? So I'll just call this one mass 1. And I'll call this one mass 2. Okay. And let's go ahead and just start putting stuff in. You should just know that big G is 6.67 times 10 to the negative 11 meters squared newtons over kilograms squared. Okay. Let's go ahead. Given we know that mass 1 is 10 kilograms. Mass 2 is 300 kilograms. We know that the r, the distance between the two objects, is 2 meters. And we also know big G, it's a constant, it's never going to change. It's like pi, 6.67 times 10 to the negative 11 newtons meters squared over kilogram squared. Unknown, what I'm looking for is how strong is the force between those two objects. The equation is right there, so I'll just jump right into substituting and solving. Substitute and solve. I usually like to start with writing the equation down. And then I start plugging stuff in. I don't know my f, so I'll leave it as a variable. Big G is going to be 6.67 times 10 to the negative 11th newtons meters squared over kilogram squared. M1, I'm calling 10 kilograms M1, and I'm calling M2 300 kilograms. And you'll start noticing what happens to these units. The reason that this stuff is the way it is, kilograms times kilograms is going to be kilograms squared, which ends up canceling with that one. Okay. R, be careful with the R. A lot of people tend to make mistakes with that R. It's R squared. Use parentheses. 2 meters, and then you square that. And once again, you're going to see what happens with those units. Those meters square, and it cancels out with that one, and so you end up with just nice round units. You usually tend to massage stuff down to make your life easier, but at this point, you're ready to put it into a calculator. But I like to, personally, I like to kind of make it easier before I put it into the calculator. So I'll put 6.67 times 10 to the negative 11 newtons meters squared over kilograms squared. Sorry for the messy handwriting. 10 times 300 is 3,000 kilograms squared. Now I'm leaving the units in so you can see what happens. This kilograms times kilograms gives you kilograms squared, and this kilograms cancel out with that kilograms. Over. 2 meters times 2 meters is 4 meters squared. And once again, the units cancel each other out. And the other thing I can do, just the extra step, is divide this out. This is just stuff that I like to do before I put into a calculator. 6.67 times 10 to the negative 11th. And we're left with newtons. 4 into 300, let's see if I can do that in my head. Was that 750 somewhere? About that. I'll just say it's 750, I think it is. Just say 750. And that's what you're going to be putting into a calculator. And I'm going to